In this chapter, we will present RIP. So we have this topology: R1, R2, R3. R1 has the loopback address 10.0.11, R2 10.0.22, and R3 10.0.33. Interface 10.0.12.0, 10.0.23.0. We will configure the interface. So interface S0 0 IP address 10.0.12.1 24. So okay, so we already configured those interface. So we just need to show display IP interface. So we have 10.0.12.2 here, 10.0.23.2 here. R3 we have a 10.0.23.3 here. So we should be able to ping the interface. That's the R1. That's R3. Now we will enable RIP. By default, it's RIP version 1 on these three routers. So R1 RIP 1 network 10.0.0.0. RIP 1 network 10.0.0.0. RIP 1 network 10.0.0.0. So now we enable RIP. Let's display the IP route table. So you can see on R1 we learn 10.0.2.0/24. Next hop is 10.0.12.2. We also learn 10.0.3.0. Same next hop because we learned this IP from R2, this IP address. We also learn 10.0.23.0, which is this interface here. So you can see the cost, the RIP, the cost actually is the hub. So 10.0.2.0/24 is one hub away. 10.0.23 is same, one hub away. But 10.0.3.0 is two hubs away, which means one hub, the other hub. There's a debug command you can use to monitor the IP, the RIP. Debug IP1. Terminal debugging. That's good enough. Do debug rip. So we stop the debug. Let's see what we get. So um, let's see what we are looking for. You see the rip sending version 1 respond on the 001 from 10.0.12.1 with and the sending respond on interface from the interface to the broadcast. Let's see we should see destination. You see here packet. Version 1 receive respond from. Let's R1 received respond from R2 on the local interface. It received version 1 and that's the destination 10.0.2.0 cost 1, 10.0.3.0 cost 2, and 10.0.23.0 cost 1. So that's the debug command. But I prefer by using the ENSP, I prefer to use the Wireshark to capture the packets. Let's see. I did some packet capture. So that's one of the one we just enable RIP. That's the first packet the R1 send it out. So it basically says RIP version 1 request, which means it will broadcast to say I'm running RIP. So source for sure is the local interface 10.0.12.1. So RIP version 1 we use the destination as the we use the broadcast as the destination, and protocol. Let's see here. We use the RIP uses UDP port 520. That's the RIP. So the second one we got is this one. So this one basically that's a RIP version 1 response from it's called response. Actually, it's the advertised. Uh, so source is still the local interface. Broadcast as the destination. Um, in this routing information, it will size see version 1 and 10.0.1.0. That's R1's loopback address. Metric 1 because that's his local, right? He will say, if you want to come to me, you need one hub away. So the another one is 10.0, 12.0. That's another local interface. Mm. The third one I captured is the third one is RIP version 1 response from R2. CD R2 sent me his source is 10.0.12.2, this interface, and it also sent to the broadcast. So it's again UDP. You can see the detail. Right, that's in this packet. That's the IP level. So IP level is IPv4. Header 20 bytes. This is about the QoS. We will talk about this later. Um, so TTL is 1. Protocol ID is UDP 17. And the source address, destination address. So another layer is layer 4 is a UDP source port 520, destination port 520. And what's in the packets? That's the routing information. So it the R2 advertise 3 subnets. One is 10.0.2.0, which is local loopback interface. 10.0.12.0 is another local interface, and 10.0.23.0 here. So I prefer to use the Wireshark to capture the packets. It's very easy to use. I will show you how to use this Wireshark. It's just from here you just see capture data, and from here you specify the router and the interface. So I click serial interface 001. I start. So that's what I get. So that's all the package I captured. So if I say I want to stop it, I see that this one. And let's see what happened here. So see, they still have some package running here. That's the RIP version 1 respond from R2 because they periodically send the update. So the same thing, same information here. So that's all the package. If you don't want to capture, so you just say stop. Now it stopped. So mm, so each that's one of each packet you can just double click and open to see the detail. Let's come back to the our topology. So this one is the we learned the routing information from R2, right? So from here you can very you can click and you can find all the detail information, like the frame is the layer 2 level. So the we use PPP protocol. Um, the layer 2 will tell the layer 3 is IP. You see protocols in frame is PPP, IP, UDP, RIP. That's layer 2, layer 3, layer 2, layer 3, layer 4. So each one you can click and you can see this data here. So all the detailed information are here. Sometimes when you start to learn this routing layer 2, layer 3 stuff sometimes is very hard to understand. But if you capture the data, you can tell the detailed information, and so it's pretty much like you can open the package and check bit by bit. So see, that's all the bit here. So on the cable itself, that's all the bit. Uh, the hardware, I mean the media itself send. But when we translate into uh, the the correct format, is like you can see all the packets, because this Wireshark is very good tools, and it is free, and is basically translate all this data into the correct format. So that's a very good way. We just take this chance to introduce. So I encourage you to use the Wireshark. Uh, Rip has a version 2, and version 2 has the a lot of advantage over the Rip version 1. Let's start to config version 2. So Rip 1, so version 2. Rip 1, version 2. So Rip 1, version 2. And let me see here. Rip 1, version 2. Um, we are running version 2. Let's check the routing information. So from here, you cannot tell too much different, but I will show you the package I captured. Here is one packet I just captured by after we enable version 2. You can see the difference, right? Version 2, it says the version 2 response. This port is version 2, and the major difference is you see the source is the same, but destination is 224.0.0.9 instead of broadcast. That's one key difference. Then another key difference is, you see here, version 1 doesn't have the in the version 1 the routing information, it doesn't have subnet mask, but the in the version 2, because it support the classless routing information, so the update in the update packet it does have the net mask, but the version 1 by default they use class 4. Next, we represent the import static route to RIP version 2. We will create another loopback interface on R3. We create a new interface, loopback 1, 172.16.4.4/24 on the R3. So our plan is on R2 we set up a static route to this network, point to this interface, and we will import this routing information into the RIP. So from here is a static route, but R1 will learn by RIP. So R2 will import this static route into the RIP. So on R1, uh, we will say IP route static 172.16.4.0.24 10.0.23.3. um, and we on the RIP. So we go to RIP 1. We will import route route static. So now if you display IP route, you should see 172.16.4.0/24. It's learned by RIP. So let's pin 172.16.4.4. 4.4. We have a route here. 172.16.4.4. Let's see what happened here. Pin 172.16.4.4. Oops, what happened here? We may create a we don't create a interface yet. One interface loop IP address 172.16.4.4.24. Yeah, that's why we couldn't ping. Let's see, we can ping this interface here. So basically on the R2, if you see the routing table, you can see 172.16.4/24 is the static routes point to R3, and here you have a RIP because you have this command and the RIP. Next, we will represent the RIP version 2 route aggregation and authentication. We will create several loopback address here, and we will aggregate, basically summarized to the RIP. We will create 4 new networks, new subnet on the R3. So interface loop to IP address 192.168.0.124. 3 1 loop 4 2 loop 5 3. So let's see, IP interface 3. So you can see these 4 new networks. So on R3, we will configure RIP1 network 192.168.0.0 1.0 2.0 3.0. Now we check the routing table here. So we learn 192.168.0.1.2. Now we have under 3. So now we will start to set up an aggregate route. So basically on R1 we learn 4 specific route 192.168 something. But what we want to is to summarize this route to 192.168.0.0. So slash to say 16. What we can do is R2 interface 0/0/1. The command is rip summarize address 192.168.0.0 255.255.0.0, which is slash 16. So now let's check the routing table here. So you see here, because on R1 you still learn 4 specific routes from R3. But on this interface you add a command. You see, I want to summarize those 4 network into one. So when R2 advertise this route, it will only advertise 1/16 routes to R1, and it will not send the specific route. But you can still be able to ping 192.168.0.1, 1.1, 2.1, and 3.1. Now we will represent the how to authenticate the RIP, which means you make the RIP protocol more secure. So the authentication is configured on the interface. So 0/0/1, you can set up RIP authentication mode is simple. Huawei. If you only set up on the R1, now you can see show IP. You can still see, but it will eventually time out. Now we configure the RIP authentication. You see RIP authentication simple Huawei, but on R2 interface 0/0/1, we don't have that command. So now if we show the routing table, we lost all the routes we used to learn from R2 because we have authentication and the password. So we can fix this to configure the same thing on the interface. So on this side, you see, we can learn the routing information here. Let's do some capture here. So capture R101 start. Let's do something here. Make it the interface 001. Actually, it's already there, but we will try to do this. Shut to shut. Okay, now we can stop. That's why last time I didn't click this one, so if I say stop, capture is still running, but now this time we stop it. Okay, now request. You can see the in the routing information when it sends request, right? It includes the authentication. You can see simple password, and the password is Huawei. In this case, if I uh, use some tools to capture the data, I can figure out what's the password you are using. So I can just break your network. Another thing is we can try to use more secured MD5 certification. Let's try on the between R2 and R3. So R2 interface 0002. We see RIP authentication mode MD5. Let's put Huawei again, and R3 interface. We just copy this RIP to here. Okay, so we should still learn the routes. So we still learn the routes from R3. Now let's capture this interface. So capture data R2 002 start. Let's wait for the update of the RIP, or we can shut down the interface. Shut. Okay, we have some RIP. So we stop. So let's see what we get here. The packets. see what's wrong with this. Okay. So now you can see the authentication is uh, it says authentication, but you cannot read like before. You can read the password. Now you couldn't tell this because it's encrypt the, the password. We still use the Huawei as the password, but it's encrypt, so we couldn't actually see the read part. We represent the RIP protocol. We configure RIP 1, RIP 2. We import static into RIP. RIP 2 we also configure the route aggregate to summarize the routes. We also use the certification. There's two modes. One is use the simple password, which can be captured by the middleman, and the other one is MD5, is very secure. Uh, so that's it. That's for the RIP. Thank you for listening.